Hey YouTube, it's Sean Powers. I am in a pretty deep funk, so I'm going to do my best to get through the end of our security section of Linux Plus. But if I'm not quite as entertaining as I normally am, we'll say that's why, and not just because I'm really a boring person. But let's talk about permissions. Oh, I should have switched to that slide, right? Let me switch to the slide. So we're going to look at there's permissions in Linux, but it gets kind of complicated pretty quickly because we have standard permissions, which actually I'm going to put a link to the video up there. From the Linux Essentials course, where I talk about permissions, standard POSIX permissions. So I'm going to go over it really, really quickly here, not explain a whole lot. But in that video, we even go over things like octal notation, which is just cool stuff. So we're going to look at standard permissions, but then we're also going to look at ACLs and then attributes. Attributes, which are like one more layer of permissions that you can put on files. All right. So we're just going to go through it really quickly, and it's not going to be exciting. That's a way to build it up, Sean. No, but let's actually go and demonstrate, first of all, basic permissions in Linux. Now, like I said, you're going to want to watch the video that I'm going to link up there because that's going to show you in depth how to handle permissions. But basically, you have three things. You have like three different sections that you can allow or disallow people to access files. There's the user that owns the file, the group that user is in, and what any other users in that group have permission to do, and then other. Meaning anybody else in the system, what they have access to do. And the three different bits that we can use, we can say they have read permission, write permission, or execute permission, each one of those on a file. I'll show you what I mean. All right, so here we have just a single file called test. If we do ls -l, it'll show us the permission string. And this first character says whether it is a file or a directory, or it could be things like a pipe or node, or all these different things, but we're just going to look at two different things. It's either going to be a D for directory or a dash right there, and that means that it is a standard file. And then the next fields here, the next characters, are the three different things. Like these first ones are the user. So the user who owns this file has read and write permission, but not execute, meaning it's not executable by the owner. Here we have read and write and not executable by anybody in the owner's group, like the group that owns this file. I'll talk about that in a second. They have the same thing. They can read to it, they can write to it, but they can't execute it. It's not executable. And then anyone else on the system can read it. So basically this file is readable by anybody on the entire system, any users, but they will not be able to write to the file because there's a dash right there. That means that it's not set on, if you will. And so nobody who is either not the owner or not in the group that is the group owner of this file will be able to write to it. They'll only be able to read to it. And of course, they won't be able to execute it either. It's not an executable file. All right. Now, executable means literally execute, like a program, unless it's a directory. And if the execute bit is set on a directory, that means you can read the contents of it. So like doing an ls in a directory. So I was able to do ls -l of this current directory. So if we were to do ls -la, we're going to, oh, there's a whole bunch of them. But what I want to show you is this, the dot directory is the current directory that we're in. And you'll see that first letter says it's a directory. And we have read, write, and execute privilege. Execute privilege means that we can read the contents of it. So if we do ls, we're going to get a response. And that's what it means if a directory is executable. So the owner or the group owner is able to see the contents of it. But other people on the system are not able to see the contents of this folder. So if they type ls home s powers, it's going to say not allowed. You're not allowed to see the contents of it because other users on the system don't have that executable bit. Now, how do you know who the owner and the group owner is? Well, that's what these fields here are. S powers is the owner, so that's me, and anybody in the S powers group, which right now is just me, but this could be a different group name, but it's not. It's, you know, S powers, S powers. So anybody in the S powers group is also going to have executable abilities in there. But somebody who is not me, not the S powers user, but is in the S powers group, they are not going to be able to write files into this folder, which is interesting. They can read stuff in here and they can see, do a listing of the files in here, but they're not going to be able to create a file in here because that write bit is not turned on for them. So that's just kind of interesting, right? So yeah, that's basically how basic privileges work. Now, if you want to change some privileges, I'm going to clear the screen because it's messy. When I did ls-a, it showed all of the files, even hidden. I guess I could show you again. ls-a shows you hidden files. Any file that starts with a dot or folder that starts with a dot is hidden and isn't shown if you just type ls. See, we only see files and folders that don't start with a dot if you just type ls. So I'm going to clear the screen. ls-l. So test is a file that has this permission. But if we wanted to change that, we would use chmod. This is going to change the permissions of a file. And to do that, we would say something like, I want the group to not have or subtract write access to test. Okay, so we build this up by saying like chmod, change the permissions on here, group -w, minus write access of the test file. Press enter, and now if we do ls-l, we're going to see what we've changed is the group trio here, like these three, read, write, execute, we have removed from the W from there. So that's what that chmod with that does. Now you can string them together too. We could say chmod group plus W, comma, other minus W, or well, I guess it doesn't already have R. Let's say other minus R. Okay, so we're going to change it now where the group user again has write access. We're going to put it back to where it was, but we're going to take away the read access of other. Okay, so the other, meaning these last three, anybody else in the system, is no longer going to have write access. So I do that, and I do ls-l, and sure enough, these last three, it used to have that read bit turned on, but now it doesn't. Now we've subtracted that, but we've also put back the write bit. So that's how you can change permissions on a file. Same thing with a folder. You do it the same exact way. And like I said, that video that I linked earlier is going to have all of this in depth and how to do it, and even how to do it with like octal notation and stuff, which is interesting in and of itself. All right, so these are basic permissions. Now, let's say we wanted to have a little bit more flexibility. Like, for example, we want to have everybody in the S-Powers group, everybody in the marketing group. Let's say the file was like owned by marketing, and we wanted to have certain permissions for marketing group, but also like Susie, a user, she's not in marketing, but we also want her to have permissions. Well, it gets really complicated when you only have the user, the group, and everyone on the system. So you want the user and everybody in the marketing group plus Susie, who's not in the marketing group, to have access to a file. You can't do that with standard permissions, but you can do that with ACLs. Okay, so with ACLs, you can do individual specific things like that. And let me show you. Let's say that we wanted everybody in the S-Powers group to have access, and we wanted, of course, S-Powers, the user, to have access, but we also wanted one other user, like Susie, to have access. You know, she's not in the S-Powers group, and she's not S-Powers. Now, using standard permissions, we could do something like sudo chown Susie test. Okay, and now if we do ls-l, we're going to see, so now Susie owns the file, and anybody in the S-Powers group, which would include S-Powers, has read and write access to it. But that gets a little bit weird because now Susie is the owner, and that's just weird. So generally, this isn't the way that you would want to do it. You'd want to use something like ACLs. So we could also change the group to something that Susie is a part of, but you can be more fine-tuned with ACLs. Okay, so I'm going to put this back. chown S-Powers test. Okay, so it's back to how it was like normal. If we do, I'll clear the screen. So these are the standard permissions. If we do get fackle, so get the ACL of test, it's going to show us the file name is test, the owner is S-Powers, the group is S-Powers. This is the user permissions. The user has read write. You know, this just basically broken this up and explained it for us, right? But we could set a specific ACL for Susie that would function outside of the standard permissions. So we could say set fackle Susie read write execute test. Oh, modify. And now if we do get fackle test, we're going to see what we've done here now is We haven't changed the file permissions. In fact, I'll show you ls-l. The file permissions are exactly the same. However, now there's a little plus here, which means there are other things that are set, meaning we've set more than could be set with standard permissions. Okay. And what we've done is, S powers, user, group, other. However, we've also set a specific ACL for Susie. Now, Susie also has read, write, execute on this file, even though she is not S powers and she's not in the S powers group. So you can do more with ACLs than you can with standard permissions, but it does get complicated pretty quickly. And so you really have to keep track of what you're doing and watch for that little plus, because that's going to show you that something else has gone on. Something else is going on with this, and the ACLs are there. But ACLs are just like a way to do more specific permissions than you can with the standard permission tools in Linux. But if you want to do some other things, you can use attributes, which are even more wacky. Okay, so with attributes, there's a bunch of them you can do. I think, let's see. If we do LSATTR, we're going to see this entirely huge string, right? This string is much bigger than the other strings that we have, right? Than this string here. But all of these attributes can be changed, and this is kind of like just the default. This is the default attributes, not a whole lot is turned on. But if we do CHATTR, chatter, for change attributes, I think if we do -H, it'll show us all of them. No, let's do man chatter, because I want to show you all the different kinds of attributes that you can do. You can, well, this is how you assign them, but the attributes, a file with an A attribute can only be opened in append mode, which is interesting, right? You won't be able to delete it or change what's in there, but you can add to the end of it. So like a log file, you could keep adding to it, but if you put the A attribute on, you can't remove what is there. A lot of them are here. Some of the more common ones are that lowercase a, but also another real common one is I, which means immutable. With the lowercase I set, you cannot change it. You can't delete it, even if you're root. So, and that's usually what you'll run across. So let's quit this. If we do CHATTR plus I on test, do sudo. Okay, so I've plus, like, added the immutable attribute to test. I had to be root to do that, so that was what sudo was all about. Now if we do LSATTR, we're going to see, so it's changed, right? This is the immutable flag. It's now on. But now watch this. So ls-l, we can see S powers owns it. But if I try to erase it, rm test, it's going to be like, oh, you can't do that. Oh, okay, let me use sudo. Let's do it as root. Sudo rm test. Nope. It's not permitted. Even though I'm root, I cannot delete this file because it is immutable. So, I mean, you can use this as a joke if, you go to somebody's system and make a bunch of files immutable and they can't delete them, even if they do it as root. But more importantly, or more usefully, you can set the immutable flag on a file and then it can't accidentally be deleted. All right, so those are the things. Like I said, the lowercase a, you can add it, and then you can append a file, but you can't erase what's there. You can't overwrite a file. You can only append to what's already there, which is an interesting attribute to add. And so those are three basic ways that you can change permissions on a file. Now, there are another couple things that we need to cover: set user ID, group user ID, and the sticky bit. Now, first of all, let's remove this attribute. So sudo change attribute -I for test, and now LSATTR test, we're going to see it's back like it was, so we can remove it now. RM test, and now boom, it's gone. Okay, so that's how you would do it. You would remove the immutable flag from the file, and then you can get rid of it. But let's clear the screen. There's these three things. So set user ID, this is setting a special bit on the user, three things like the first three. And so let's do touch test. Okay, so it's there. What we can do is chmod, just like if we were doing regular permissions, but if you were to add user, so the owner, so the first three, plus S, that's going to be to set the set user ID bit on test. And now if we do ls-l, we're going to see that what's happened here is instead of an X, this is now an S. And why it's a capital S versus a lowercase s, if it, this is how we can tell underneath that set user ID if it's executable or not. Now, it was not executable, so that's why this is a capital S. If we were to now do chmod user plus X on test and then do ls minus L, we're going to see now it's a lowercase s. So that's just how you can tell whether the hidden X underneath is set or not. So if it's a capital, it was not executable. If it's a lowercase, it was executable underneath, and now it is S. Now, the difference here is if you see something with set user ID, this bit is set as S. What that means is when it is executed, it runs with the permission of whoever owns the file. And that seems a little strange, I know, but let's do an ls minus L of user bin. Okay, if we do this and we go looking for umount, for example, okay, so to unmount a file system uses umount, right? And with this set user ID bit set, which it is set, when this is executed by anybody, like a plain old user, it executes with the permission of whoever owns the file. Okay, so since root owns this file, if me as S-Powers were to execute umount, it would execute as the root user. It's kind of like a little bit like sudo, but it's it executes as whoever owns it with that user's permission. And so some things that need to have system access, but you still want to have a user do it, use the set user ID bit. Now, this is a huge security risk, so you only do this for files or for programs that are specifically designed with security in mind, so that they're not going to do anything nefarious if somebody has, you know, a regular user can have that access and make it function. So that's what set user ID. Set group ID, it does the same exact sort of thing. Let's see if we can find one of those. Here, SSH agent. This is another program on our system in user bin. And this one has the set group ID. Now to do this, we would just do chmod G plus S, you know, to add that set group ID in that second string of, you know, the read, write, execute. Well, now this is readable, not writable, and it is executable because there's a lowercase s that it changed to. But what this does is when you execute SSH agent, it runs with the permissions of the group that owns it. So in this case, underscore SSH, that is very similar to set user ID, but it's set group ID. So instead of looking at the owner of the file, it looks at the group of the file. Okay, hopefully that makes sense. This isn't something you normally set. This is something either set user ID or group user ID. These are usually on very specific system files, you know, that we have here. Now, the thing about group user ID, it does something interesting on a folder. Now for set user ID, you change that on a folder, it doesn't do anything at all. But the group user ID bit, if you set it on a folder, suddenly, whenever a file is I'll just show you. Let's show you. All right, I'll do clear. What do we have in here? Okay, I'm going to get rid of that just because we already demonstrated that one. So I'm going to make a folder. So mkdir Susie. Okay, so I've made this directory called Susie, and now if we do ls minus L, we'll see, but it's still owned by me. So I'm going to change it to be owned by Susie. So sudo chmod, or no, ch group Susie for the Susie folder. Okay, so now if we do ls minus L, we're going to see, so S-Powers is the owner, Susie is the group. Now, normally, if I go into the Susie group and I create a new file, so touch test1, and do ls minus L, we're going to see it's owned by the person and the group, the main group of the user who created it, right? So test1 is created, it's owned by me and my group. But if we change and we do chmod group plus S for dot Susie, or just dot, this is the current folder we're in, so Susie. Let me go back a folder, sorry if that was confusing. ls minus L, sudo chmod group plus S for Susie. And now ls minus L, we're going to see that, okay, Now the group this folder has the set group ID bit set right here. See, so that S right there in place of the X. And now if we go back in there, even as the S powers user, so I'm going to go back into SUSY, I'm going to touch test2. And now check this out, ls-l. Anything that's created in here is now going to have the group ownership of whatever group owns that file that has it set to set group ID. So since set group ID is set to SUSY and the name of the folder, maybe I shouldn't have named it SUSY, but that's the folder that we set it to is the SUSY folder. Now anything created in here is going to automatically belong to the group that this folder belongs to. So that's why I created a file and now it has the group of SUSY. So that's set group ID. The one last thing we need to cover is the sticky bit. And I'll put a video that I talk about sticky bit a whole lot up here, but sticky bit only functions on folders. So set user ID only functions on files. Set group ID does something to both a file and a folder. The sticky bit only works on folders. It used to work on executables. This is just a little bit of trivia. It used to work on executables in that if you set the sticky bit on an executable, it would stay in swap space, so you'd be able to load it faster the next time, but that's long gone. That doesn't do anything. So now the sticky bit only applies to folders. And if you have the sticky bit, which is the last three, for other, so again, set user ID is the user read, write, execute, group user ID is the group read, write, execute. The sticky bit is the other read, write, execute trio there. If you add, turn that bit on, then you can't, I'll show you, because the temp folder is a perfect example of this. So let's go back to our computer here. If we go into just the root drive and we do ls-l and we look at the temp folder here. So the temp folder has the sticky bit turned on. Now here's a really bizarre thing. Rather than an S, for some reason, it's denoted with a T for sticky bit. But you'll see here, this folder has T in place of the X, and the same thing, if it was an executable, it would be a capital T. But so T is in that place in the last three. And what this means is if you create a file in a folder with the sticky bit on, another user can't delete it on you. Right? So if you create a file in there, it's not able to be deleted by somebody else. Normally, if you create a folder or if you create a file, another person can just delete it. But in this case, you cannot. And so I'll show you. First of all, let's just go back to our home folder, make directory sticky. ls-l, you'll see sticky is just a regular folder there. In order to make that last thing there, we do the same thing. chmod other plus s sticky, and now ls-l, plus t sticky, ls-l. Now we're going to see that we turned on the sticky bit. Again, why it's t and not s, I have no idea. But now the sticky bit is there. And so if we create a file in there, but somebody else is not going to be able to delete it. So we'll go back to the var folder, or to the temp folder, because that's on your system. That's pretty much the only place sticky bit applies. But we'll go into the temp folder, and in here I have all these files. I'm going to make a file as S powers. I'm going to say touch don't delete me. Okay, so I've touched this file called don't delete me. It's right up here. It's owned by S powers. Everybody has read access to it. Now, normally a person would be able to just delete that file, but here I'm logged in over here as SUSY. If SUSY were to come in and go to the temp folder, look in here. Oh, I see Shawn created something called don't delete me. I'm going to delete that. Don't delete me. It's going to say, you sure you want to remove it? Yes. Oh, you can't. It's not permitted. And normally it would say, you sure you want to delete that write protected file? And if you say yes, it would delete it. And I'll show you. Let's remove the sticky bit real quick. So cd ... I'm going to say sudo chmod other -t, the temp folder. And I've broken my system. Don't do this and leave it, okay? But if we do ls-l, we're going to see now the temp folder is just a regular folder, okay? So I'm going to go back in there, cd temp. Now I'm going to touch no delete. All right, so it's in there. And Now Susie comes back into a folder that doesn't have the sticky bit turned on. She's like, let's see. Oh, he created a file called no delete. I'm going to get rid of it. RM, no delete. Are you sure you want to remove that write protected file? Yes. And boom, it's gone. Now, the don't delete me is still there. But now, even though she couldn't remove that before, RM, don't delete me? You sure you want to remove that? Yes. And now Susie is just the deletinator and she's deleting everything. So yeah, that's the wacky permissions that you have with like sticky bit and set user ID and group user ID. But ACLs allow you to do more than you can with just a user, a group, and an other. That allows you to make specific entries for like specific users or specific groups on a file or a folder. So it's like standard permissions, but with like asterisk, like plus Susie like has full access. And then attributes are a little bit different. The only ones you generally see are going to be like the I attribute, which is immutable, which means you just cannot delete it. You can't get rid of it. You can't change it no matter what until you remove that attribute. But that's how you can manipulate files on your system more than just the permissions that you see standard read, write, execute, read, write, execute, read, write, execute. Anyway, I hope that was helpful. I urge you to play around with those things. I know we went over it quick. We've gone over most of this before, especially in Linux Essentials, but specifically with ACLs and attributes, that's new information. So play with those, look at the man pages to get a feel for all that they do, and have fun. Maybe prank your system. I'm going to go and put the sticky bit back on my temp folder because otherwise things won't work right on my system. Remember to learn everything, do what you love, and most importantly, be kind. I'll see you in the next video.